I'm going to be explaining how we can find the volume of a sphere using the volume formula. First off, a sphere is a three-dimensional circle, and its volume is given using this formula: 4/3 times r cubed times pi. That's commonly how it's given to us, although that's not a very useful way of writing it as far as like the steps that we would take mathematically. So I like to rewrite it. I like to cube my radius first. Then I like to take that value and multiply that by 4 pi, and then divide all of that by 3. Not the only way you can do it. You can choose to do it in whatever order you want, but we want to make sure and cube our radius first before we do any multiplication or division. So if you're given the radius, the formula is not too bad. So the way to make it a little bit more difficult is to give maybe a diameter or some other measures. So in this first example, we're given a water tank that's a sphere and it has a diameter of 45 meters. So in order to use our formula, we need the radius. So let's cut that diameter in half and use 22.5 as our radius. We'll plug that into our formula. Again, I think it's just easiest if we're using our calculator to cube our radius first. Multiply that value by 4 and pi, and then divide that entire quantity by 3. If you do that in the correct order, you should get about 47,712-ish cubic meters. And then the second part of this question is asking us to convert to a unit of volume that maybe we're more familiar with. Obviously, we don't see a whole lot of liquids that we buy in the store in containers that are using cubic meters. They're usually using liters or gallons or quarts or things like that. So we're going to do a little conversion here, convert it to something we're a little bit more familiar with. If there are 1,000 liters in every cubic meter, then how many liters are in our 47,712-ish cubic meters? We'll set up a proportion, making sure that our units are on the same level. I could have put both of these cubic meters on top of our ratios. It doesn't matter. As long as similar units are on the same level, then it should work out. We're going to cross multiply to solve our proportion. And in doing so, it's just a multiplication conversion. And we get about 47,712,938 liters. And again, liters is a unit of volume already. Do not cube that. That would be totally different. Next example is very similar, except we're just talking about a hot air balloon. So it's still a spherical shape. We're given the diameter here, and we're going to cut that in half to get the radius first. Then we'll plug our radius into our formula. We'll cube that radius, multiply by 4 and pi, and divide that by 3. And we get about 137,258-ish cubic feet. Again, not a unit that we are totally familiar with and working outside in the real world. So let's put it into something that we're familiar with, like gallons. If there's 1 gallon for every 0.134 cubic feet, then how many gallons was 137,258-ish cubic feet? Cross multiply to solve our proportion. This turns into 2 steps. Cross multiplying gives us just this linear equation right here. We'll divide by 0.134 to solve, and we'll get a really big number: 1,024,316 gallons. So a pretty big hot air balloon there, requiring a lot of helium. Again, to step it up with spheres, you could have what's called a composite figure. And sometimes in a composite figure, you either have a sphere or you have what we have here, which is half a sphere, which we call a hemisphere. And so if we have our volume of a sphere formula, we'll just divide by 2, and we'll get half a sphere or a hemisphere. One thing you can do, a little trick here, rather than dividing your answer here by 2, you could just divide by 6 instead of 3 here, and that would take care of your hemisphere volume without doing an additional step. Dividing by 3 and then dividing by 2 is the same as dividing by 6. So you could take this top part and divide it by 6, and you would get the half sphere volume. All right, so we have enough information to get our hemisphere volume. We're going to cube that radius, multiply by 4 pi, divide it by 3, and then divide it by 2, or just divide this by 6 and get 1,072-ish cubic meters. So there's part of our composite figure. We also have a cone. So in order to find its volume, we would need the height of the cone, which is not given to us. So we need to use an imaginary right triangle inside that cone, where we know the hypotenuse is 17 and one of the legs is 8, and we'll be able to use the Pythagorean theorem to solve for the height of the cone. We'll take our hypotenuse squared minus our leg squared to get the other leg, and we find that our height is 15. So now we have what we need to find the cone volume. We'll do the base area, which is the area of the circle, so radius squared times pi, times the height of the cone, 15, and we'll divide that whole thing by 3, and we get about 1,005-ish cubic centimeters. The total volume of the composite figure would be the combination of those two volumes. So add your two volumes together, and we get about 2,077.64 cubic centimeters. And one last thing that we can do to kind of challenge ourselves when we're dealing with volume of any kind is to be able to play with multiple formulas. So for example, here we're going to start off with the surface area of a sphere and then be able to work into the volume of the sphere. So knowing what the surface area is, we can set up our formula for surface area of a sphere and work backwards to solve for the radius. We'll need that radius to find our volume. So let's try and solve for r here. Surface area of a sphere is 4r squared times pi, so we'll set that equal to the surface area given to us, 314. We'll try and solve for r by undoing everything around it, so we can divide by 4, we can divide by pi. We can do that in 2 steps or just in 1 step as I did. And then we'll get our r squared value. Still not quite r yet, but we're close. One more step. To undo a square, we'll use its root, so square root both sides. And we get a radius that's pretty close to 5, but we're not done yet, so don't round that value. We don't want to change it and make it less accurate, so let's keep 3 decimal places going here. We'll plug that radius value into our volume equation. We'll cube it, multiply by 4 and pi, and divide by 3, and we get our volume, about 523 2/10 of a cubic inch. So there's a few examples dealing with volume of a sphere. Use that formula, and good luck.